One of the skills that one must master in order to be successful in chemistry is dimensional analysis, or in English, canceling out units. To do so, we need conversion factors. So the conversion factors we will look at today will be converting between moles and atoms, and moles and grams. With regard to moles and atoms, 1 mole equals Avogadro's number of atoms, or 6.022 times 10 to the 23rd. 1 mole also equals the mass of any element from the periodic table. And so we will be using these two important conversions for many of our future chapters, and the key to success in chemistry relies on the student's ability to convert between moles and atoms and moles and grams. So let's see how these conversions would play out in typical chemistry problems. In this problem, we have a silver ring containing 1.1 times 10 to the 22nd silver atoms. The question is, how many moles of silver are in the ring? Well, first, we should always identify what we are given. In this case, 1.1 times 10 to the 22nd atoms of silver, and what we must solve for, moles of silver. Now, we do have a conversion that 1 mole equals Avogadro's number of atoms. So this will be a one-step solution converting from atoms to moles. We begin by putting down our given, which is 1.1 times 10 to the 22nd atoms of silver. We will use our conversion factor of 1 mole times Avogadro's number of atoms. Now, the 1 mole and the 6.022 times 10 to the 23rd, which goes on top and which goes on bottom? To determine that, we look at what we were given. We were given atoms, and therefore we must convert out of atoms and into moles. To cancel out our atoms, we need the Avogadro's number of atoms on bottom. Therefore, we cancel our units, and we are now into moles. So, we would end up with 1.8266 times 10 to the negative second moles of silver. Since this number of atoms is less than Avogadro's number, the answer makes sense. The only additional hint I would give you is make sure that you know how to place your numbers in scientific notation in your calculator. If you are unsure how to place these type of numbers in your calculator, stop by my classroom and let's go over and review exactly how you would approach this per your calculator. Also remember that various calculators require these numbers to be placed in different ways. Some require parentheses, while others require just the number. So become familiar with your calculator and make sure you have it anytime you have quizzes or tests to ensure success. Let's look at a problem where we must calculate the number of atoms in 2.54 moles of copper. We are given 2.54 moles of copper, and we must convert to atoms. Again, a one-step conversion. We will be using 1 mole equals Avogadro's number of atoms. As always, start off with what is given in the problem. In this case, 2.45 moles of copper. Now in this problem, because moles must be canceled and we must be in units of atoms, we will have moles on the bottom and we will have Avogadro's number of atoms on top. We do the math, 2.54 times Avogadro's number, and we have an answer of 1.48 times 10 to the 24th atoms of copper. Atoms are small, and so the number of atoms being small makes sense. When we calculate conversions between moles and mass, the mass of 1 mole of an atom from the periodic table is known as the molar mass. And it's this molar mass-mole ratio that we can use to convert between units of moles and units of mass. Let's look at a few examples and see how we would approach these problems. In this chart, before we begin with our example problems, there are a few things that I would like for you to see. First off, let's look at these elements. Notice that each of these elements have Avogadro's number of atoms, so that 1 mole equals Avogadro's number of atoms. However, each of these elements has a different mass from the periodic table. So 1 mole of hydrogen would equal 1.008, since that's the weight of hydrogen on the periodic table, but 1 mole of calcium would weigh 40.08 because that's the weight of calcium. And because of this, this will allow us to convert between moles of atoms, moles and grams, and then grams and atoms. So this is a wonderful setup that we can use in future problems. In this problem, we will calculate the moles of sulfur in 57.8 grams of sulfur. So our given is 57.8 grams of sulfur. We must find moles of sulfur. This is a one-step conversion. Using 1 mole of sulfur equals the weight of sulfur from the periodic table, which is 32.07. We put our given 57.8 grams of sulfur, and in this case, which one of these will be on the top and which will be on the bottom of our fraction is determined by the fact that we are given grams. We must convert out of grams and into moles. Therefore, 1 mole will be on top, 32.07 grams will be on bottom, grams cancels, answer 1.80 moles of sulfur. In this problem, we will be converting between atoms and grams. How many copper atoms are in a penny weighing 3.10 grams? So, in this problem, 3.10 grams of copper is given. We are asked to find atoms. There is no direct conversion between grams and atoms. Therefore, we must convert from grams to moles and moles to atoms. This means we will use the conversion factor of 1 mole equals the weight from the periodic table of copper, 63.55 grams, and 1 mole equals Avogadro's number of atoms. Our given is 3.10 grams of copper. We must cancel out of grams and get into units of moles. Therefore, 1 mole of copper is on top, 63.55 grams of copper is on bottom. Again, the 63.55 grams is the weight of copper from the periodic table. Grams cancels. We are now in moles. To convert out of moles and into atoms, we will use the conversion factor of 1 mole equals Avogadro's number of atoms. Since we must cancel out of moles, moles will be on bottom. Avogadro's number will be on top. Moles cancels. We are now in units of atoms. So we multiply 3.10 times Avogadro's number. We get an answer. We divide it by 63.55 and we get 2.94 times 10 to the 22nd atoms of copper. In this final example, we have to calculate between mass and moles. Calculate the mass of 1.75 moles of water. We are given 1.75 moles of water. We are asked to find grams of water. This will be a one-step conversion, converting between moles and grams. So we will use the conversion factor of 1 mole equals the mass of water from the periodic table. We get the mass of water because we have 2 hydrogens, 1 oxygen. Hydrogen weighs 1, oxygen weighs 16, add up, and we get the 18. Our problem gave us 1.75 moles of water. We must convert out of moles and into grams. Therefore, 1 mole is on bottom. The mass of water from the periodic table is on top. Moles cancels. We are in units of grams. We do the math, and we get 31.5 grams of water.